In this example, we'll be looking at the sum of 2 to the k over k factorial. And one thing we can keep in mind is that when we see a k factorial or n factorial, any expression with a factorial, it would be useful to use the ratio test. And similarly, if I have like an exponential term, like here we have 2 to the k, we know the ratio test will also be good. So this is going to be good for the ratio test in these two terms. Okay, so we're going to apply the ratio test. So let's take the limit as k goes to infinity, ak plus 1 over ak. So ak plus 1 will be the expression we get from putting in k plus 1. So it's 2 to the k plus 1 over k plus 1 factorial. And then the reciprocal of that would be k factorial over 2 to the k. Okay, now we can see how this simplifies. Notice that the 2 to the k divides with the 2 to the k plus 1 up here. So the k's divide, and I'm left with a 2 in the numerator. And remembering that for k plus 1 factorial, we can always write that as k plus 1 times k factorial. And after doing that, then we can divide out the k factorial here and here. So I'm just left with a k plus 1 there in the denominator. So what remains now is the limit as n goes to infinity of 2 over k plus 1. Clearly now, as k goes to infinity here, k instead of n, as k goes to infinity, this limit equals to 0. And since this came out to be less than 1, remember for the ratio test that tells us that the series is convergent. And actually more exactly, it says it's absolutely convergent, which implies convergent. So in this example, we have something that resembles the geometric series 1 over 3 to the n, but it has this extra 2 term here. So that tells us that maybe we want to do a comparison test with comparing it to 1 over 3 to the n. And in this case, it might be simple enough to just do a direct comparison. Let's just check to see how these two series compare. So the terms of this series compared with the terms of this series, we notice that because this one has a larger denominator, you got 2 added to 3 to the n here. So the value here is larger, meaning the overall quotient is smaller. And since we know that 1 over 3 to the n is a convergent geometric series, then this one must also converge since it has smaller terms. Okay, so here we can say, and since the series 1 over 3 to the n, well, let's kind of specify here why we know this one is convergent. Notice it's a geometric series, right? You got a common ratio of 1/3, right? It's just adding 1/3 plus 1/3 squared plus 1/3 to the third, and so on. So you're just adding up powers of 1/3. And so we know this is a convergent geometric series. And we know it's convergent since here r is equal to 1/3. And since the absolute value of r is less than 1, implies convergent, right? Okay. So since we're comparing it with something that we know is convergent, and the terms of this series are smaller than it, we can say that it's also convergent by the comparison test. So we can say that 1 over 2 plus 3 to the n is also convergent since the terms are smaller by the ratio test. Or, sorry, not by the ratio test, by the comparison test.